Now, that said, let's start with another subtopic under this session. That is, let's look at the problem of cost minimization and output maximization. We've always said that the firm is a rational producer or a rational entity, and the firm will always want to make profit since it is rational. Now, for the firm to make profit, the first thing that the firm will have to do is to minimize its expenditure or minimize its cost. When it's able to minimize cost and able to maximize output, then the firm is likely to be able to maximize its profit. So, how do we minimize our cost? First, we need to be able to determine the output that the firm is going to use. And in this session, we're going to assume that the firm is going to use just two inputs. That is, labor and capital. And we're going to assume that these two inputs are homogeneous. In that said, or that assumed, we are going to say that the cost of the firm, the total cost of the firm is, which we are going to represent by C, is equal to our small r multiplied by K plus W multiplied by R, multiplied by L, where R is the cost or the price of the input capital, and W is the price for labor. This we can call it the isocost equation. Remember, under production, we saw the isoquant, and the isoquant shows you the various amount or the various combination of labor and capital that will produce the same amount of the output. In this case, it is a various combination of labor and capital that the firm employs that yield the same cost. So based on that, we can generate an equation, and this equation is what we are going to say is the isocost, and it shows you the combination of labor and capital that the firm can produce given a fixed amount of money or a fixed expenditure. In this regard, we can make K the subject of the equation, and our equation then becomes C divided by R minus W divided by R multiplied by your labor. C divided by R is a constant, and it is a vertical intercept, or the intercept on the vertical axis. While W divided by R, that is the price of labor divided by the price of capital, gives you the slope of our isocost. This isocost also shows us the relationship that exists between the amount of labor and capital. In other words, it shows us a trade-off between labor and capital. Okay. And our isocost is downward sloping, as we can see from the diagram. From left to right, that will mean that it has a negative slope. And that is why when you go back to the previous slide, you realize that W divided by R, which we are saying is a slope, has a negative attached to it, meaning that if we increase capital, we must be willing to reduce labor. And when we want to increase labor, capital must be reduced in order to incur the same expenditure, which we are saying it is fixed, or the same cost. So intuitively, the firm will have to equate the rate at which K can be traded for L in the production to the rate at which the firm trades in the market for labor and capital. Now, remember, we've seen the isocost, and we saw that the isocost is bends towards the origin. Okay. And the further away it is from the origin, the higher the output of it. And we also remember, we also said the isocost, the slope of the isoquant is given by the marginal rate of technical substitution capital for labor. And that the marginal rate of substitution tells us the rate at which the firm wants to substitute one of the labor for capital for labor. Here, the slope of the ISO cost is telling us the rate at which the firm can do that substitution. Now, for us to minimize our cost, what we have to do is let the ISO cost be tangential to the isoquant. And at that point of tangency, there will be, we will be minimizing cost. So in other words, what we are doing is we are minimizing cost subject to the output of the firm, or the output that the firm wants to produce. Now, remember when we did the isoquant, what we did was, we said that for every point along the isoquant, the slope is different, or the marginal rate of substitution is different as we move along this isoquant. So over here, what we are doing is we are trying to measure the slope of the isoquant at a particular point. So we look for where the isocost is tangential to the isoquant, and at that point, the slope of the isoquant is the same as the slope of the isocost. So in other words, at that point, what we are saying is the rate at which the firm wants to trade capital for labor is the same as the rate at which the firm can do that trade in the market. So in other words, that is where the firm maximizes its output and minimizes its cost. And this is what we call the constraint optimization problem. Okay. So if we assume that the production function is given as Q equals to F of, that's a function of K and labor, capital and labor, and the ISO cost is expressed as cost, which is C, equals to the price of capital multiplied by the quantity of capital plus the price of labor multiplied by the amount of labor employed. We can then minimize our cost subject to our output. So cost minimization of input choice can mathematically be derived by setting up our Lagrangian equation. Remember, we've seen Lagrangian when we did consumer behavior. The same principle applies here. So we set our Lagrangian equation to be L, capital L, where capital L is the Lagrangian, plus equals to the price of capital multiplied by the amount of capital plus the amount of the price of labor multiplied by the amount of labor employed plus a lambda into brackets our output minus the function K of L, K and L, the function K and L. Taking the first order condition, we minimize the Lagrangian subject to the two inputs and the Lagrangian multiplier. So the L, capital L, which is the Lagrangian subject to labor, is equal to the W, that's the wage rate, minus the lambda as a function multiplied by the F, the L, where L is the product function, where F is the product function, and that is equal to 0. That's for taking the first order condition. Taking the first order condition of the Lagrangian function with respect to capital will yield us the price of capital minus lambda times the product function with respect to that of capital. Now, if you look at it, the F, the L is the marginal product of labor, and the F, the K, is the marginal product of capital. Then when we take the first order condition subject to the Lagrangian multiplier, it gives us output minus F of K and L, and that is also equal to 0. When we solve these three equations simultaneously, we're going to have labor W divided by R, that is the price of labor divided by the price of capital, equals to the marginal product of labor divided by the marginal product of capital. And remember, from the production function, the marginal product of labor divided by the marginal product of capital is the marginal rate of substitution, capital for labor. So this expression is simply saying that the cost minimization or cost minimizing firm should equate the marginal rate of technical substitution for the two inputs to the ratio of their prices. And that is the marginal rate of substitution, labor for capital, must be equal to the wage divided by the price of capital. And this equation can also be rewritten as the marginal product of capital divided by the price of capital equal to the marginal product of labor divided by the price of labor. So in other words, we are saying that for the firm to maximize or for the firm to minimize its cost, the marginal productivity per cedi spent should be the same for all inputs. So in other words, the marginal product of labor divided by the price of labor must be equal to the marginal product of capital divided by the price of capital. So if you have more than two inputs, remember here we've assumed just two inputs. When you have more than two inputs, what we're going to have is to make sure that the marginal product per cedi spent for all the four inputs happens to be the same. And when that happens, the firm minimizes its cost. This cost minimization problem is similar to the individual expenditure minimization problem that we studied earlier under consumer behavior. Now, so all that we've done is to look at cost minimization. Another way of looking at this is to look at it from the other way around. That is in terms of output. So we try to maximize our output subject to the cost. So we determine the cost. That this is the cost that we want to incur. What is the maximum output that we can produce? So in this case, we set our Lagrangian, and this time our output function is stated as f of k and L plus a lambda, that's a Lagrangian multiplier, multiplied by cost. So it is the output subject to maximizing output subject to cost. Again, we go to the same procedure and we take the first order condition, and we do that with respect to the two input that are used in production, that's labor and capital. So we do that in the first equation, and we have the capital L divided by with respect to labor, or the first order condition of the Lagrangian function subject to labor, and that gives us the F, the L minus lambda W, which is equal to 0. And for the second, we take the first order condition of the Lagrangian subject to capital, and that gives us the F, the K minus lambda R, and which is also equal to 0. Then we do for the Lagrangian multiplier. So we take the first order condition subject to the Lagrangian multiplier, and that gives us the total cost minus the price of labor multiplied by the amount of labor employed minus capital times the price of capital, and all must be equal to 0. Again, when we manipulate this, we are going to arrive at the same equation that we came to, and it is the same as the price of wages divided by the price of labor divided by the price of capital equal to the marginal product of labor divided by the marginal product of capital. And in so doing, we maximize our output subject to our cost. And therefore, for the firm to maximize profit, for the firm to maximize its output, it will do so by equating the marginal rate of substitution to the price ratio of the two inputs. And note that these are similar this is similar to that of cost minimization, but the only difference is that in the case of production, we hold production constant when we are trying to minimize cost, and we hold cost constant when we try to maximize production. Then another session that we are going to look at is, another thing that we're going to look at under this session is the input function. When, after taking the first order condition, should we solve them simultaneously? We are going to have the input function for labor and capital. So solving these equations simultaneously, we will arrive at the demand for labor and also the demand for capital. And these input demand functions will depend on the quantity of output that a firm chooses to produce. The higher the output that a firm chooses to produce, the more of this input that a firm is going to require. So in other words, this demand for this input is referred to as derived demand. That is, the input are not demanded for their own use, but then the amount of it that you demand is dependent on the output that you decide to produce. The next topic we're going to look at is the expansion part. Remember, under consumer behavior, we said when the income of the consumer increases, that means the budget line is going to shift outward. And that will be tangential to a higher indifference curve, and a new equilibrium will be arrived at. In other words, we're talking about the income consumption curve. This is similar to the income consumption curve. The question is, what happens if expenditure increases? Expenditure on the two inputs increases, given that the price of the input remain constant. So that will mean that you are increasing the total amount that you're going to incur, the total amount that you are going to spend on these two inputs, even though the price of the input are constant. Now, what happens is when expenditure increases, that will mean that we're going to move to a higher isoquant, and our isocost will be tangential to a higher isoquant, and that is what we are looking at. And when it moves to it is tangential to a higher isoquant, that means that we're going to require more of capital and labor to produce that higher output, because as you move to a higher isoquant, that means that output level is increasing. And this part, when we trace this equilibrium part, it is what we are referring to as the expansion part. So the locus of cost minimization tangencies gives the firm's expansion part. Now, just as we use the income consumption curve to illustrate the type of commodity that we are dealing with, in the same way, we can use this expansion part to determine the type of commodity input that we are dealing with. Remember, we said under consumer behavior, using the income consumption curve, we can determine whether the commodity in question is a normal good or an inferior good. Here also, the expansion part can help us distinguish between a normal and an inferior input. By definition, a normal input is one whose quantity increases with the expansion of output, while an inferior input is one whose quantity falls as output increases. Now, because cost minimization requires that the RTS always be set equal to the input prices, that is, the marginal rate of substitution must be equal to the input ratio of the input prices, and because this ratio is assumed constant, the shape of the expansion part will be determined by where a particular marginal rate of substitution occurs on successive higher isoquants. If the production function exhibits constant returns to scale, then the expansion part will be a straight line, because in that case, the marginal rate of substitution depends on only the price ratio of capital to be 1. The ratio of capital to labor to be equal to 1. That ratio will be constant along such a linear expansion path. But then, Our expansion path need not be positive all the time. It can be negative, and as illustrated from the curve we have, when you move, as you move, you realize that the expansion path is positive until we get to isoquant, the third isoquant Q3, and it becomes a downward sloping path. So mathematically, the output expansion path is obtained by the equation seen here. Now, I have a question that I've added to the slides, and we are saying that using graph, establish the relationship between the average variable cost, the average cost curve, the average fixed cost, and the marginal cost. Mathematically show the similarities and differences between the cost minimization and the output maximization. For references for this particular session happens to be Variant 2014, Intermediate Microeconomics, the 9th edition of that book, and it is published by Norton and Company. Then we have Jeffrey Perloff, Microeconomics, that is Pearson Education, and this is the 6th edition. And also Nicholson, Water, and Schneider, 2011, Microeconomic Theory, Basic Principles and Extensions. Thank you.